Hello, good day everyone. I am one of the random YouTube persons that try to help out in solving college questions. My name is David, and solving college questions happens to be my priority as I try to help out those who have similar challenges when I also faced something like that in college. A cantilever 1.5 meter long is loaded with a uniformly distributed load of 2 kN round over a length of 1.25 meters. It also carries a point load of 3 kN at a distance of 0.25 meters. Draw the shear force and bending moment diagram of the cantilever. Alright, so let's get to the answer. So I trying to draw the diagram so you can actually get clearer understanding. So I have drawn this line. So the next thing is just to draw the readings with the accurate information of what it takes. Okay, so from here, I bring it up like this, and I bring it up again, okay, and I take it up again. Are you getting it? So let us continue the way we are drawing. So this is the wall. I hope you can see it. So I try to, sorry for not being accurate with my lines, but I just want you can try to be accurate with yours. And this is the spring, which is here. This is the spring. So let's name this point. Let's name this point A. Let's name that side point A. So we've tried to name this point A, right? So the ending part, let it be labeled as point B. Now, on the spring, let it be labeled as C, and this part, let it be labeled as D. I hope you can see it very well. Now, this is D here. I want D to be here so you can see it very well. This is C. This is C, and this is point B. Okay, so from point A to point D is just what? It's just 0.25 meters. From point A to point D is what? Is 0.25 meters. 0.25 meters. While from point D to point C, from point D to point C, sorry, I'm just trying to get something done over there. From point C to point D, it is from point C to point D. From point D to point C, that is just what? That is just 1 meter. While from point C to point B, that is 0.25 meters. 0.25 meters, right? Okay, so I draw my line here. Okay, sorry for the drawing. The drawing is not that perfect, but just that we get answers to what is really challenging. So from point D to point B, that is what? That is 1.25 meters. 1.25 what? 1.25 meters. Okay. Now, so we move on. Remember that there is a turning moment here. Sorry. Remember that there's a turning moment here. There's a turning moment here. And the turning moment here signifies what? 5.94 kilonewton. Sorry. 5.94 kilonewton meter. And this point is 1.5 meter. When the side, when you add it, it gives you what? 5.5 kilowatt, 5.5 kilonewton. On this same line, you have 5.5 kilowatt, kilonewton. I hope you are getting it. Now this 1.5 meters here, the 1.5 meters here can be extended to this side. It is something here. It can also be extended to what? Can also be extended to this side. Now, if this place 5.5, then we are going to draw. We are going to have another diagram in this place. We are going to have another diagram. And one of the diagrams that we are going to have is when we have something like this, it's just, and I'm not perfect with this diagram, so that's why I said you should try to just manage. So now remember that our lines are still here, and our lines are still being drawn from here. So is a positive, is a positive, is a 3.5 kilonewton, and this is 0.5. Are you getting it? Okay. So we have from our readings, this will be 5.94. Sorry, 5.94 kilonewton meter. So as it goes, it decreases. So this one is 5.565, and it comes here to give you your 2 degree. It gives you your 2 degree WME, and this has a 0.0625. Remember that there is a turning point here, which is 2 degree curve. Have you gotten it? So the equation for shear and moment goes thus: that for the line AB, it becomes your 0 is less than or equals to x, which is less than 0.25 meters. I hope you can see it very well. All right, so solving it independently. So we have our wall here, we have another one here, and this is our what? This is our wall, and it gives rise to what is here. So we have our x directed toward this point, and this is our direction for this, which is 5.94 kilonewton meter, and upward here is what? 5.5 kilonewton. Now remember that this is always our what? Our horizontal direction, Vx, which is directed downward, so that oppositely directed, so that this one becomes our m. Let's just name it alpha. Let's name it alpha or gamma. So at the end of the day, I am having my Vx to be 5.5 kilonewton, and my Mx to be equals to minus 5.94 plus 5.5x. Okay, so for the line DC, my DC becomes 0.25 is less than x, less than 1.25 meters. Close the bracket. So solving it independently as well. I just have to change this so that I won't waste my books. Now for the line DC, or should I just write it again? So let's just say DC is 0.25 is less than x is less than 1.25 meters. So I have it such that it is somewhere like this, and my line with cantilever is directed here. This is my spring. And remember that this one is 2 kilonewton what? Meter. This is what? This is X. And it's oppositely directed here. And that's anti-clockwise. 5.94 kilonewton meter. And this is the same as what? 5.5 kilonewton. Now from here, directed to here is what? Is 0.25 meters. While from here, I have while from here, sorry for the pause. While from here, I have my X. Remember, so my Vx here again. This is clockwise. So I have my what? My Mx. So therefore, my Vx is what? 5.5 minus 2x. I hope you can see it. 5.5 minus 2x. Sorry, this one is okay. While my mx is minus 5.94 plus 5.5 into bracket 0.25 plus x minus 2x squared over 2. So why my b? So continuation from where we stopped. So let's calculate the line BC. BC, this is what? This is line BC, which is 0 is less than or equals to x, less than or equals to 0.25 meters. Now, I want to draw the diagram for the BC so we can get our values. Now, the spring is, so our spring is mostly up over here. So I have from here to here to be my x, so that I have 2 kilonewton meter here, 2 kilonewton meter, when this point is my x. Now, recall that at this point, there is a line moving here, which is mx, and this is my point vx, so that at this line, I have x. So, to get the readings to get the readings of this particular spring, so I have my Vx minus 2x equals to 0. I have my Vx to be equals to what? To be 2x. And this implies, okay, this implies that my Vx inverse is what? 2x minus 3. So at the end of the day, I'm having mx plus 2x squared over 2 equals to equals to 0. So therefore, my mx equals to minus x squared. Okay, so let's continue. For the whole string now, we've gotten them independently. So for the whole string now, this is the wall. This is the wall, and I have, sorry for this line not being straight, but just try to make yours straight. This is just a rough sketch. Then I draw my string. This is my string. When this line is A and the ending line is B, this is D, and of course our C should be here. Our C should be here. And recall that our C is having 3 kilonewton, while this is having 2 kilonewton per meter. So the line here is drawn to have 0.25 meters. and from here up, from here is 1 meter up to this point, and from this point here we have 0.25. Now from this point again, I have 1.25 meters, and it's extended towards the outside. This is 1.25, and from here again, this is a turning point. This is a turning point MA with I hope you are getting it. I'm just trying to make a rough calculation so you can actually settle down to check it well. Okay, so this is 1.5 meters. Then my VA is here. So the next thing we want to do now is let us apply the equilibrium of equation to give the support reactions. Let us apply the equilibrium. Let us apply the equilibrium of equation to give the support reactions, so that summation of EFY is what? Is 0. So my VA is equals to 2 times 1.25 plus 3, which is 5.5 kilonewton. That's what? Equation 1. Summation of MA is 0. So we have minus MA plus 3 times 1.25 plus 2 times 1.25 times is 1.25 times 1.25 over 2 plus 0.25 equals to 0. So therefore my MA is 5.94 kilonewton meter. Now this is the whole solution to everything, and please, if you haven't subscribed, please subscribe. Trust me, I will always drop more solutions to your questions. Thank you.